July 1st, 2025. Atlas, the asteroid terrestrial impact last alert system, flagged a faint smear sliding through Aquila. Within hours, the community realized they were watching an object that had wandered interstellar space for eons. It was tagged 3I Atlas, our third confirmed visitor from beyond the Sun's family. Early fits showed a textbook hyperbolic track. Fast, unbound. The kind of arc that says, I didn't form here. Velocity? Tens of kilometers far too quick to be captive to our star. The expectation, flare a little near perihelion, maybe grow a tail, then disappear toward the galactic interior. But refinement kills complacency. Through late summer 2025, better astrometry locked in a trajectory threading the outer system and aimed at Jupiter. Not near Jupiter in the hand-wavy way, but alarmingly close. Best fit closest approach, March 16th, 2026, about 0358 AU. That proximity puts it well inside Jupiter's gravitational sphere of influence. For a body born light years away to arrive with that precision at that well, nerves tingle. Why care? Because Jupiter is a machine for redirecting or collecting things. Its gravity sculpts orbits. Its vast magnetosphere corrals particles over millions of kilometers. And circling it are Europa, Ganymede, Callisto, prime targets in the search for habitable chemistry. If anything dust-rich and organic brushes this system, the consequences could be chemical or biological numbers that make people uncomfortable. Trajectory models began spitting out probabilities. If you assume random interstellar arrivals, the chance of one threading a path this tailored to Jupiter can be tiny. Some estimates 4% depending on inputs. That's not impossible, just rare enough to ask hard questions. Natural explanations exist. Selection bias, solar neighborhood streams, resonances that funnel travelers. But the pattern invites speculation too. Could sustained outgassing act as a micro-thrust over months, guiding the path millimeter by millimeter into a Jovian rendezvous? That's not sci-fi. Non-gravitational forces are standard in comet dynamics. It's the persistence and directionality that would matter when comet behavior raises eyebrows. 3 Atlas doesn't need to break physics to be interesting. Reports point to jets that seem persistently oriented rather than chaotically sweeping with rotation, the kind of anisotropy that, integrated over time, nudges the orbit. Spectra added spice. An elevated CO2-H2O ratio, on the order of 8:1 in some analyses, compared to many solar-borne comets, hinting at a frigid carbon-rich birthplace. Meanwhile, nickel signatures with little corresponding iron are odd, because Fe and Ni typically travel together from star forging to rock. Exotic chemistry could be natural. Strange birthplaces do strange things, but it forces fresh models. Morphology hasn't been boring either. A normal dust tail away from the sun, plus features resembling anti-tails and asymmetric comi that don't line up neatly with simple solar pressure expectations. Each anomaly alone is explainable. Together, they form a stack that keeps theorists busy. Why Jupiter's backyard matters. Jupiter itself is an unlandable pressure cooker, but its ocean worlds steal the show. Europa, a global ocean beneath under 10 to 15 kilometers of ice. Possible plumes, rock-water contact for energetic chemistry. Ganymede, largest moon, intrinsic magnetic field, layered ice-ocean structure, partial radiation shielding. Callisto, ancient surface, likely deep ocean. A memory palace for deposited material. Jupiter's magnetosphere can trap dust and ions, spiraling them toward moons or into the planet. A dusty, outgassing 3I Atlas flying through this environment could shed organics that later drift onto ice, percolate into oceans, or, if tidal stress breaks the nucleus, arrive by impact. Any of those pathways could tweak local chemistry for decades to ages. The shrinking window from discovery, July 2025, to Jovian flyby, March 2026, is 9 months. No time to build a bespoke mission. That leaves telescopes, creative scheduling, and any spacecraft already nearby. Proposals to retarget assets like Juno wrestle with fuel, risk, and scientific trade-offs. Earth-based spectroscopy and imaging will carry much of the load. Post-encounter, missions like JUICE might study lingering signatures if dust hangs around. Microthrust, mega-outcome comet jets are nature's tiny rocket engines. Even milli-Newton scale thrust applied consistently accumulates delta V, If vents are positioned or activated in a way that keeps pushing in useful directions, not just sunward, it can bend a path subtly but decisively. That's the kernel of the steering by outgassing idea, not fireworks, just patience and geometry. Chemistry that doesn't quite fit the template: A, high CO2 dominance, nickel without matching iron, persistent anti-tail behavior, and an asymmetric coma can all be given natural backstories. Extreme formation zones, interstellar processing, unusual rotation states, perspective effects. But the combination is, at minimum, uncommon for what we're used to from homegrown comets. And we've only logged 3 interstellar visitors with real detail so far. Tiny sample sizes breed big uncertainties. The moons as laboratories on Europa. Any interstellar organics settling onto fractures could slowly migrate to the ocean, feeding prebiotic chemistry, or interacting with any indigenous ecosystem if it exists. Ganymede's magnetic field might funnel charged dust toward polar regions, localized delivery zones that, over time, could seed material downward. Callisto's quiet geology could preserve interstellar fallout like a long-term archive. Jupiter's radiation belts and field lines will sort and energize what 3 Atlas sheds, creating complex, model-worthy pathways from space into ice and ocean. The hypothesis people avoid, and why it persists. Most researchers prefer mundane answers until data force otherwise. Yet because directed Panspermia would use exactly this playbook, aim a volatile-rich courier at a giant planet with icy moons, the topic surfaces whenever trajectories look too neat. Unverified. Social media signals don't help. They add noise, not evidence. The sober view, natural first, keep collecting data, but don't blindfold yourself to low probability, high-impact alternatives. What to watch on and around March 16th, 2026. 3 broad outcomes. Clean flyby, a gravity slingshot, brightening near approach, then fading outbound. Good science, minimal long-term Jovian fallout. Temporary capture, resonance, lingering orbits through the magnetosphere. Dust arcs or rings, repeated moon crossings. System-wide deposition over months, years. Fragmentation, nucleus breaks. Some pieces impact Jupiter or the moons. Fresh craters, transient atmospheric features, and deep chemical delivery. Spectroscopy, what's released. Photometry, how it changes. High cadence imaging, morphology, possible breakup. And magnetospheric measurements, particle injections, will separate these scenarios. 3 Atlas is probably a natural interstellar comet with unusually instructive quirks. But even if it's nothing more than that, its pass through Jupiter's domain is a once-in-a-lifetime experiment in how foreign material meets an ocean-moon system. If there's even a sliver of a chance we're watching the start of a chemical story on Europa, Ganymede, or Callisto, it deserves our best eyes now, before the visitor vanishes back into the dark.